Invasive blood tests can be a pain, sometimes literally, but that could soon be alleviated with the help of your smartphone. Find out how this week on Light Matters. This is Light Matters for May 13th, 2015. I'm your host, Justine Murphy. On this week's show, we'll check out an exhibition happening in London that showcases miniature illuminated sculptures made from recycled electronics. And we talk about a new smartphone microscope that is capable of analyzing blood to detect infections. But first, we explore a new algorithm that could make high-quality video panoramas possible. Even non-professionals may someday be able to create high-quality video panoramas using multiple cameras with the help of a new algorithm. The method smooths out distortions that routinely occur when video feeds from unstructured camera arrays are combined to create a single panoramic video. It corrects for parallax, the apparent difference in position of an object caused by different camera angles, as well as image warping that occurs because of slight timing differences between cameras. Both parallax and image warping lead to visible discontinuities, ghosting, and other imperfections seen in existing approaches. The new technique automatically analyzes the images from the cameras to estimate position and alignment of each camera, which eliminates the need for calibration and allows flexible positioning. A team led by Disney Research Zurich demonstrated the technique using as many as 14 cameras, generating panoramic videos with resolutions ranging from 10 to 100 megapixels. They presented their work last week at Eurographics 2015. A research team led by engineers at UC Berkeley has developed a mobile phone microscope capable of analyzing blood. Able to provide critical information to healthcare workers in the field, Cellscope LOA could help revive efforts to eradicate debilitating diseases in Africa. Biophotonics editor Rod Pedrati explains.
Thanks, Justine. Representing the university's next generation of its Cellscope technology, Cellscope LOA's primary purpose is to automatically detect and quantify bodily infections caused by parasitic worms. Aptly named after the African eyeworm Loa loa, which can lead to loiasis, the CDC cites one of the infection's several symptoms as being able to observe the worm crawling across the surface of the eye. According to Dr. Daniel Fletcher, Associate Chair and Professor of Bioengineering at UC Berkeley, this is the first device that combines imaging technology, hardware as well as software automation to create a complete diagnostic solution. Now, the researchers paired a smartphone with a 3D printed plastic base where a sample of blood is positioned. This base incorporates LED lights, microcontrollers, gears, circuitry, as well as a USB port. Control of the device is automated through a proprietary app, which was also developed by the researchers. With one touch of the screen, the phone communicates via Bluetooth to controllers in the base, which initiates the analysis of the blood sample. Gears move the sample in front of the camera, and an algorithm analyzes the telltale wriggling motion of the worms from the phone's captured video. The worm count is then displayed on screen. The entire process only takes about 2 minutes. The university teamed up with the National Institute of Allergy and Infectious Diseases, as well as with collaborators from Cameroon and France, to conduct a pilot study in Cameroon, right where health officials have been battling the parasitic diseases onchocercosis and lymphatic filariasis. In fact, lymphatic filariasis is the second leading cause of disability worldwide. As of now, the standard method of screening for Loa loa involves technicians manually counting the worms in a blood smear using conventional laboratory microscopes, which makes the process completely impractical for use in the field. According to Fletcher, this advancement shows just what technology can do to fill a void for populations that are suffering from terrible but treatable diseases. The researchers are now expanding the study of Cellscope LOA to about 40,000 people in Cameroon. After the break, we'll look at how an artist in London is creating self-illuminating sculptures with recycled electronics to mark the International Year of Light 2015.
Hi there, I'm Dr. Sandeep Raja and I'm the Incremental Product Manager for our optical encoder products. Today I'd like to introduce you to our brand new encoder, which is the Atom encoder, which is this product here. What differentiates this encoder system from our other incremental products is we've managed to incorporate our filtering optics design and miniaturize the encoder package. This means you get the benefits of having a small encoder system whilst maintaining high reliability, high metrology performance, and superior data immunity that we have with our other optical encoder products that Renishaw sells today. For more information on Renishaw encoder products, please visit www.renishaw.com/encoders.
Celebrations worldwide continue to commemorate with flair the International Year of Light. The Electric Microcosm features the work of UK-based artist Ben Yates. Drawing inspiration from mathematics, sci-fi entertainment, and all things Japanese and counterculture, he has created an Electricities exhibit that combines practicality and the fine and applied arts in sculptures made from recycled electronics. Each provides its own illumination, according to Yates, and all are meant to showcase the beauty and design that is intrinsic to circuitry. One piece in particular, Electricity Mountain, is a miniature cityscape made from recycled circuit boards, model railway figurines, LEDs, and a plasma plate. Yates then built an octagonal table made out of clear acrylic and a toughened glass top around the sculpture to turn it into a stunning yet practical piece of furniture. Yates' Dark Arts exhibition includes some of the Electricity sculptures. Like the others, these pieces are striking cityscapes that are self-illuminating, and all can double as artwork used for practical purposes. The Electric Microcosm exhibit will be on display at Gallery 286 in London from May 13th to the 20th. And that's it for this week's show. Join us next week for a wrap-up of Clio 2015 happening right now in San Jose. Stop by the Photonics Media booth at 1318 if you're in town. Thanks for watching. We'll see you right here next week on Light Matters.